So this particular series is started as an effort to become more intentional about the way I code, things like that. In this particular video, we are going to go through interpreter, the logs interpreter from the crafting interpreters book. So at current stage, we are debugging a particular bug with the garbage collector that we have implemented, where it's unable to find values that is supposed to be in the scope. So looking at the test that we are trying to run, the test that we are trying to run basically has outer function and a middle function, and within this middle function, these two values from the outer function scope should be retrieved as an up value, and the final active command is actually the print command, which takes variables from both the mid scope and the outer scope. So when we actually try to run the test that we have here, what we'll find out is that it returns a variable undefined. So we have had some debugging previously, and so some of the debugging notes. We found out that the compiler generates a get global, 4 different get globals, get go 3, 4, 5, 6 get global in the inner function, where it should have been up values for these two. So I'm debugging now. So the compiler, the only place that actually determines which is the getter and setter function is this particular place here. And let's try to do a breakpoint on this function here. Local. And closure. Okay, let's try to see what it's trying to retrieve. It's trying to retrieve A now, the first variable. So if you look at the code right here, if you look at the compiler, it should be a function of the name. What's the function name here? Closing function. Right. Okay, we can go to the particular function to see. Okay. So this is the function it's pointed to by the current compiler. And the name or inner. So we can see that this is this particular scope right here. Then we run a local resolveLocal on it. You probably can't find it because this scope is supposed to be empty. So yes, let's resolveLocal, we look at both the compiler and the name, it should not be able to find it. So when it fails to run the resolveLocal, what will happen is you run the resolve upvalue, and in here you'll be running resolveLocal on the enclosing scope, which in this case, confirm, print down name again, still looking for A. Compiler here. So this function is mid. So looking at the code, variable A is still not in mid, but mid should have two different variables declared here, C and D. Let's check whether that's the case. So in resolveLocal, what you actually do is try to get a table of the compiler search to see whether the variables is in the local scope. So in this case, what we're going to do is to find out whether search has any items. So here we see three items, which on the code should be C, D, and the function inner. So let's check that out. So let's take a look at what the table has. So the list of entries basically saying the key and value. Second is empty, third one is on. Right, because it's hashed, so we can't really know what the value is. But okay, at hash value number 2, we have the key. The value is 1 over here. So it should be C. Let's check that out. Wrong. C should be marked with a value 3 and not as 1. So that's a bit wonky here. Let's put that down. Variable C seems to have a value of 1. Let's check other entries here. Variable D also has a value 2. Okay, so this doesn't actually correspond to the actual value of the in search table. Okay, in search table, variable C seems to have a value of 1 and D the value of 2. These correspond to position in the local scope. Okay, so it should be able to get C and D easily, right? Three items. Let's try hash number 4. Nothing. 5, 6, 7. Okay, in 7 we have another key here, and this should correspond to the object inner. Actually, looking at the generated bytecode, I don't really have it here, but looking at generated bytecode, in the mid function, the last return here should be also resolveLocal. Right. So let's continue. So far so good. So on this scope, we'll be looking at the compiler that is of the function. Here. Okay, there's a name here. Outer. Right, from the code, we're checking the outer scope now, and we should be able to find the value A in here. So what we are going to do now is to so you'll go through these values here, search. So what we want to see is that right, count of 3. Yes. First entry, second entry, entry. Okay, so this should be the value A. Right. Okay, so we are at line number 842 right now. Haven't entered the function yet, so let's go down a line. Table get, right? This should return something, and we should return the index. You should be able to get the value of the position. So let's see if it actually succeeds. Okay, so -1. So this actually doesn't return a value here. Okay, where is this? This is line 51. Okay, so now when you enter the function of table get to see whether it's correct. So let's open up the table.c file. Get. We will find an entry easily with the key. Do we have the key? We are still in the function resolve. We are still at line 851, so we are still in scope for all the variables that we need. Let's see. So this should be the key CC30D0. Okay, let's see whether the compiler has it. This looks different, right? For some reason, when we run token string, this Okay. So for some reason, when we run token string, this returns a different address. Okay. Let's try to run token string one more time. And every single time it gives me a... No, not every single time. It gives me a different value each time. Okay, let's just... Paste. My stuff. Okay. Okay. So from here, token string in to be a different object string. We don't match, so we don't get a match. So we need to see how token string is actually getting the value. So if you look at table.get, what happens is you use find entry, and find entry actually checks if the key is hash equals. So we actually check the pointer. And the pointer value is the same, but in our case, the token string function here don't seem to be able to give me the correct string. So let's look at copy string. What is copy string? Object. Okay. Let's put copy string. Okay, by right, should be able to find the string in here as an intent string. So let's see. Okay, object.c. Okay, object.c. Okay, the hash is the same, but the intent string is obtained from vm.strings. Let's take a look at what we have. On 6, by right, we should be able to find both of these inside. Okay, so according to the logs, we should be able to find both this and this. For consistency, let's just put it here. We'll find two, only this in the, only this should be generated, and this should not be in the strings table. VM string, the 6 entries here, and let's take a look at the entries. Okay, so we have on of 6 but capacity of 16, so let's values to go through. Okay, so we have over here the key as outer. Okay, And we have outer. So outer is a global variable here. Okay, let's over here. And 55 so outer is a global name, the name that is stored in the global scope, and we see it there. Okay. Drive. Okay, the name is there. So these are all function names. Okay. Inner is still a function name. Of A. And this is the magic key 0D0. Okay, let's try next. Oh, okay. We have A, but we created that, right? We created that. We called the clock. Intro. Right, so we actually only create the string and we are in token string, so it's not added to the not really added to the table find strings. Let's see. Let's see where. Right. So in the string, you locate string, and this is where we actually put the string onto the book, onto the table. We have with us over here a function that allocates an object, and in here we set the string. So, question then, where did this particular magic string come from? Where did this particular magic string come from? Right, you need to figure out where this is being created. Okay, so go here to figure out where the op string or the compiler such is created. Okay, so where is the code that actually creates this string? So who adds into compiler search dot entries? So compiler is a compiler specific object, so it should be here. I should be setting it. You should be calling the same token string function. Okay, let's try to do a breakpoint on this token string and run the whole thing again. Let's just clear all breakpoints. Okay, delete command with clear all breakpoints. Okay. Before is I'm going to open up Grok here. I'm going to insert a breakpoint at token string. Oh, wait. Let me say same string. Okay, let's check that again. Table set this token string here to compiler.c, and we actually try to resolve local. It should be also from string. Okay, whatever the case, let's break a point and run this test. 24 launcher. Okay, print my name. Right, outer, okay. Okay, outer. A, right, A. Right, A. Could it be that when I expand the table, I never insert it back, but it's unlikely because clock and throw, these are keywords, they are native keywords, they are from there from the start, so shouldn't be that case. Okay, A. Is A used? Okay, once this is done by right, the copy string function should be inserting a value into my vm.strings. Before I do this, let's check. I have a count of 3. Less than 3, nothing. 3. 3. Shred. Outer. So I have outer, I have block, I have the last one, throw. Outer, clock, throw. These are the 3 variables that I have. And when I run this thing, it should be, so my string should have 4. Right. So I should have just newly added in one new string, and that string should have the address outer block. Okay. Right. True. So oh, okay, wait, let me just try that again. some silly stuff. I have capacity of 8. That means my things end at 7, 6, 4, 3, 2, 1. But so I've not actually added 2. My vm.strings did not increase in the entries. I have a variable boolean. Can recognize a key just by coincidence. Let me check again. Is my entries length even 8? Yeah, my capacity is 8. Going on here. Okay, so I have clock string somehow. Yeah, why? That's strange. The hash is the same, the next is the same. Got upon the same object. It does probably the same object. What's going on? But that doesn't really matter because have I? No. I ran. I'm supposed to have 4. I don't have it anymore. Okay, so let's set a line on this instead. Object 548. Object the line 48. And let's run the thing again. Breakpoint object say I 48. I am allocating clock. Okay. So it is outer A, I should be allocating. Okay, rank 5, rank 1, I should be allocating the string table set. How to go in? Step into this function. My claim is that it never adds to the table. Okay, let's step into this function. Is this true? This is not true yet. Leave alone. I'm not at 75 yet. Barely halfway. This should give it nothing. Okay, actually, let me look at the entry. What I'm doing is vm set. Okay, I have with me here 30 c8 and vm.strings. 38. So right, so this pointer 38 3 5 6 0 3 5 should be 5 0 yes. C8 is 6. Okay, I am here. I want to find name. It's boolean entry true. Is it new key? It is new key. I did see table.count become false, so this should be true. Okay. Let's see, right? 6. Okay. Now it's a key. Okay. So right now, if I print vm dot entry 6, people see myself allocating the key there, and when I deconstruct, it should be right, so value is a value. Value equals to value. What is value here? Value here is in the scope, so I can print it. New. The value here is new. Okay. Okay. String B by right now, when I do vm.strings6, I should be able to have my string A. Let's say no, this is not true. See it, something changed this. Right. Something altered this address. Okay, so something touched. And let's prove that I have correctly. Right. The value should be this. Okay, for some reason, this changed. Be a memory issue, so let's try fixing it by using the relocate uses malloc instead of the block version that we have. Malloc. Okay, let's do it. Right, so I want to do the same breakpoint here. Yeah, 48, right? Okay. And here I want to run my test. Okay. And in here I print my strings and contain. B is still being in strings interest. Okay, so let's look at this address and see where I actually changed. Is this the breakpoint that we want? BB00 BBA2A. Oh, I locked it. Okay. Let's swap it back so that our logs is correct. And breakpoint member save it. Okay. And if I print vm.strings entry 6 right now. Okay, let's try to look at it first. Because it's just the first one. Okay, let's continue. EC30CA. EC30CA. Okay, consistent. Okay, so I want to check. This is not touched by anybody. So ADB create memory how do I break point? Break point and strings.entries. It's not a value. Break. No. Create breakpoint. Break and memory is touched. Watch. Yes, that's right. I want both watch. Okay, watch. Entry 6. Okay, so continue. Oh. It's too big, so do this. vm.strings. Okay, just try one thing. Oh, this won't change. Yes. Okay. Continue. Oh, no. Continue. Okay, continue. Right, so I'm setting value for A and it changed expected, right? Expected. What's this? Oh, same thing. No. It's 974 102. What's that? Delete? Why would that delete? Of course, it will delete. What garbage word? Okay, so garbage collector is causing my string to be removed. That's strange. Okay. That's not very correct. See some logs in. I kind of this here. Let's just run it, right? Let's just run it. I watched some endpoints and I kind of delete, and when I do the backtrace, it actually branch off from table set. Branch off from table set when I try to adjust capacity. Okay. This is expected, I guess. So do backtrace on this and right. V. vm.string.entries never change. Okay, anyways, if it's changed, set to 0. A tableRemoveWhite. Okay, and I am basically deleting the entry. Okay, let's tableRemoveWhite. For every single thing I go in and do, I wanna readjust capacity. Right. Okay, so in table set, I saw this and I'm like, okay, how to adjust my capacity? And so I go and relocate everything. So I adjust my capacity, and in garbage collecting, it will remove white. So, and under this particular scope, I saw that my check is not marked. And therefore, I am okay. I don't know if this why I have an issue. Okay. So somehow it was white is hitting my key. Why? Because key dot object. My key dot object is not marked. Because it's not marked. This is not marked. Therefore, it's removed. And I found it and I removed it, and that caused me to this. Okay. Let's continue. I now upgrade allocate B2. Let's look at vm.strings now. Still the same vm.strings, just that for some reason my entries is now B. Basically my entry now is B. And my number is basically messed up. Let's check this out. If I remove tableRemoveWhite, build it again. Let's see whether this works. It returns 10. This works. So return 10. It should return 10. Test user. It should return 10 and it works. Here is Reading my key because it's not marked. Okay. Let's look at tableRemoveWhite. So right, so let's mark this page as to read, and we'll continue in the next round. Okay, so with references and string, this is something that we must do. For but just really not just implementation but more implementation and a reason for tableRemoveWhite. Okay. Tune in for the next session. Thank you. Bye bye.